It takes 1 calorie to move 1 gram of water by 1 degree Celsius, okay? That's how much heat it requires. So, if I had 1 gram of water sitting at 40 degrees Celsius, and I wanted to move it to 80 degrees Celsius, I'd need to put in 40 calories of energy. That would be enough to do that, wherever it's coming from, whether I'm heating it up with, putting it in a hot object or whatever else. So that's what the calorie basically means. That means that I can move all the way from 100 to 0, or 0 to 100, and all it required for 1 gram is 100 calories. So if I had 10 grams, it's going to be 1,000 calories, etc. Interestingly, whereas between 100 and all the way down to 0, 1 calorie to move it 1 gram by 1 degree. Okay. However, when we get to 0, C, something else happens there. And we know what happens there is it will either freeze or thaw, depending on which way we're coming. As we continue to go in that direction, it's going to freeze. It's much more difficult to freeze a gram of water than it is to change the temperature of a gram of water. That change of phase that takes place takes 79.7 calories per gram. And notice it's not per gram per degree C, because after it freezes, you're still sitting at 0 degrees. You have no change in temperature. On the other side, if you're going up in this direction or down in this direction, one way you're giving the energy to the system, the other way you're taking it out, it requires 540 calories per gram to change 1 gram of water from liquid to steam at 100 degrees. No change in temperature, takes 540. So as a result, we use this fact and we say, if I've got a drink that's too warm, I know how to make it cooler. I think I'll put some ice in there. And if I put a little bit of ice in there, it's going to make my drink cooler. Now, unfortunately, if you put too much ice in there, unless you're drinking water, it's going to water down your drink. But this is so powerful. This is 80 times as powerful as the water. And so 1 gram of ice, which isn't very much, could move 1 gram of water by 80 degrees Celsius, or remove 4 grams by 20 degrees Celsius. And 20 degrees Celsius is room temperature slightly above that. So you could take a drink from 20 degrees, from room temperature down to almost 0 with not very much mass of ice at all. Okay. Again, the equation that we end up with is just that all of these Q's, when you add them up, that's a symbol that means summation, all of them together is going to be 0. That means anything that comes in cold and warms up, anything that comes in warm is going to cool down. We're going to end up in some equilibrium place. Some of them are going to have negative signs, some are going to have positive signs. But the bottom line is that when I add all those Q's up, and I'm going to need a separate Q to deal with the fact that there's freezing here, that's a different term. I'm just going to have this as the term, that times whatever the mass is. But I just need to figure out what all the Q's are and add them all up.